This is cool. Miss Leone, what is this?
Well, this is a rock.
Oh, cool. It's not a volcano?
No, this is not a volcano. This is actually a rock. And what's kind of cool, and I feel like I could tell you about this, but I might not know 100% what's going on here. But sometimes rocks will form, and like this guy right here, this is a different rock that was close by, where you get an original rock, and then you get like a little crack that forms in the rock, and then water gets in that crack, and then other rocks kind of like come out of solution. Like if you've ever, have you ever made like rock crystals or anything like that? Have you guys ever done anything like that?
Mr. Corbett's room, they do those.
Okay, so sometimes there's some science experiments that with approval of your parents, you might be able to look up online, but where you can actually take something like really salty water and grow little crystals out of it. But this is kind of the same deal, but it's in another rock. And so you get these little things forming in the rock, and then they look different. This one's really crazy though. I don't really entirely know what's going on here. Even I don't know what's going on.
Could you even classify that? I mean, if
I think it's an igneous rock, but it could be metamorphic. And the only way I think I would be able to tell is if I took it and put it under a microscope.
Okay.
So, but I'm going to call it an igneous rock. It might have come from a volcano.
I will let you call it an igneous rock, but I will say it is. It was one time sedimentary then metamorphosized into an igneous rock.
This is true. There's some pretty cool rocks out there, and you know what? Even if you don't know what it is, you can keep learning.
Yes,
that's the cool thing about rocks.
Science in general, my favorite.
There you go.
Thank you.
You're welcome.
3 weeks later.
Oh, hey, I didn't see you there. We're picking up rocks. We're going to look at them and try to decide what kind of rocks they are. So we're going to put some of these in our pockets or in our mouths and take them home. And then we're going to do a rock identification lab.
20 minutes later.
We are back from the beach, and we are now going to look at all the rocks that I found while I was down there, except that I didn't really find any of them there. These are all from school because we have this rocks and minerals unit that we do, so pretend. Okay, so what we're gonna do, if you look at your sheets on Canvas and or my blog or wherever you would find these, we are going to put these rocks into 3 different categories. Okay, so you're gonna look at the characteristics. The categories are metamorphic, sedimentary, and igneous. And the way you can remember some of those, sedimentary, sediment is little tiny pieces, and metamorphic is, if you remember caterpillars turning to butterflies, it's a process called metamorphosis. And metamorphic rock is going through a process of change. And then there is igneous, if you remember ignite. When you ignite something, you set it on fire, and so it's really super hot. And that might help you. All right, we are going to start on this sheet, identifying rock types. And the first one we're gonna look at is coal. And this, if you were in school doing this with me, you would notice that it says color here. The color, that's little dots on each of the rocks so that you could identify it. The type of rock itself isn't a mystery. The mystery is going to be what category it goes in, the 3 main classifications, okay? Here we go. As you can see, what I've done is I've put them into 3 piles, ignore those, because of some characteristics of them. So coal is the first one on our list. And coal, the problem with doing this is you can't feel these, so you have to trust me. Coal is very light compared to another black rock, this one, that isn't in the same category. And you can kind of sort of, well, no, you can't. It would chip off really easily if you were to take it and bang it against another rock, which I'm not going to do because I don't want to make a mess. So this one, coal is considered sedimentary rock, right? And one of the characteristics, if you look at this sheet, it says that they're formed by tiny pieces of rock that are getting cemented together. They can contain fossils, which I don't see any fossils in this. They can feel, you can see or feel the sand or pebbles. I don't really feel that, but they can be more crumbly, and that's why we're putting it in the sedimentary category, because they can, and they're lighter, so that's another characteristic. The other one I have in this same pile, this is sandstone. Sandstone, the name gives it away. It's made up of little particles of sand that are cementing together. And so this is the sediment, you know, kind of gets stuck and starts coming together. And you're going to learn all about this in the next assignment, so I'm not going to go there just yet. But that is also sedimentary. This one you have seen before. We tested this one with acid. Do you remember what it's called? Yeah. What is it?
Limestone.
Limestone. It has calcite. It reacted to acid. But this one, if you look nice and close, you can see the fossils in it. So that is a characteristic of sedimentary rock. Okay? So those are our 3 sedimentary rocks. All right, these 2 rocks I put together, they are in a category that we're calling metamorphic. And one of the biggest clues about metamorphic rocks is if they have layers or bands. So this one is really obvious, right? This one's called gneiss, G-N-E-I-S-S, not N-I-C-E. So gneiss, you can see definite bands or layers, and they're different colors. This one also has layers. You can kind of sort of tell, like it's chipped off in a nice flat layer. This one, it's not really different colors though, but some of them would be of this same thing. This is called phyllite, and phyllite, if I had another sample of it, you would probably see the layers a little better, but this one happens to be all the same, right? Metamorphic rocks, if you look at your sheet, they are formed under a lot of heat and pressure. In another lab that you're going to see that I'm going to be posting very soon, you're going to see how that works. So igneous rock is made from magma cooling. So the characteristic that these 2 share, granite and gabbro, is that they have lots of crystals in it. Okay, the granite you saw when we were doing the lab with acid, and it did not react because it has quartz and not calcite. And gabbro is just a rock that's got lots and lots of shiny bits in it, lots of big crystals. The other one that everybody knows if they've played Minecraft is obsidian. Obsidian doesn't really have big crystals in it, but it's super, super shiny. And it was used, and maybe still used, to make spearheads and knives and things like that, because when you bang it against something else, it can come off into really sharp pieces that will cut you. Yeah, so that is igneous rock. Last part of this lab is that after you looked at all of those and classified them, I would come around and give you this rock, and you're going to try to figure out what it is. You have 2 choices. It's either kimberlite or garnet schist. And so the idea here is you're out hiking and you find this rock and you're trying to figure out what it is. And so you're looking at the different characteristics. On your sheet, it has the characteristics of both of those types of rock. So it says for kimberlite, it's igneous, gray, and it sometimes contains garnets, and it contains diamonds, but not always in every sample. So maybe a great big piece might have a diamond in it, right? For garnet schist, it's metamorphic. It's also gray. It can sometimes have garnets in it, and it doesn't contain diamonds. Well, do you really think I would give you a rock that contained diamonds? I doubt it. Okay, so when we look at this, there's a couple of things that we would do. First of all, one is igneous and one is metamorphic. I don't know about you, but I can see some definite bands in there. Do you see the bands? Yeah. So the bands are going to tell me that it's probably metamorphic. Both were gray. Both can sometimes have garnets in them, but this one definitely does. Can you see the garnets? Yeah, I remember that. Yeah, so the garnets could be in both of them, but it's definitely in this one, and no diamonds. But I think what gives it away is the fact that it's definitely metamorphic. So we said coal can, sometimes it's crumbly. The sample I have really isn't, but if we were in class, I would have shown you that. So we're going to call that sedimentary. So we decided that, where is that? That's Gabbro, right? Yeah. So Gabbro has large crystals in it. And that we decided was going to make it definitely has bands or layers. And that makes it metamorphic. Has lots of shiny crystals in it. And that meant that it is igneous. The sample has lots of fossils. And one of the characteristics of sedimentary rock is it has fossils. Hey, shush up, Frisbee. Obsidian is very shiny and not edible. And so we said that is igneous. See the layers? Okay, and so if it has layers, it is metamorphic. Made of sand, right? And it can be crumbly and feel lighter, right? So I'm going to put crumbly and lighter. Sedimentary. It's rock right here, and we said what it's called is garnet. Hey. Schist, and it is layers, and that makes it metamorphic. Hooray. I just have a few more rocks that I want to show you. These I like to have in class. A couple years ago, we went on a road trip to see all kinds of volcanoes, and this is rock that's around the Cinder Cone volcano, the Newberry crater in Oregon. And so it's everywhere, and I just thought it was cool. But no, I did not pick it up. I actually bought it in a store. I was trying to do the right thing, right? But you can definitely see the little holes in it because the magma cooled and there was gas bubbles. Yeah, really cool. This one is one of my favorites for everybody to look at because you look at it and it looks like a piece of chalk, right? But then I tell everybody smell it. This is sulfur. This is the stinky stuff that comes out of volcano vents and things like that, hot springs sometimes, and it smells supposedly like rotten eggs. I don't know about you, but I've never smelled a rotten egg, a real rotten egg. But it also smells like farts, and I think most of you smell farts. Yeah. All right. And this last one. Did that hurt? No, that one, I have a great big giant rock of that at school, and I usually throw it at somebody. It's called Pumice, and it is really lightweight. It's super light. And so usually I play a joke on people with that because it's got tons and tons of little holes in it, and it actually floats. It's a rock that floats. So that was, yeah, those are some of them that I would have shown you in class, but you're not in class, I'm sorry. So, yeah, wasn't this fun? I'm glad we got to look at all these rocks together. We're almost done with this chapter, and then we get to move on to other fun things. I'm sorry I'm not going to get to see you in real life anytime soon, but I'll see you on Zoom if we keep doing Zoom. So have a fabulous, yeah.
Whatever day it is.
Yeah, I don't even know what day it is. It's spring break for me, but yeah, have a good one. I will see you next time on Miss Lanigan's super cool science show thing. Yeah. Frisbee, what kind do you think this is? Look, it looks like it has layers in it. Look at this one. Oh, it's a shell.